Okay, everybody, this is my second video describing how to solve a problem that is referred to as an opposite direction problem. In my last video, I showed you how to do this two ways. The first way would be to try to just do some basic math in your head and eliminate the incorrect answers and thus get to the correct answer. And then we also talked about using a table. Okay, so let's just read this quickly. We've got two trains that are traveling in opposite directions of each other. One leaves at 7 a.m. The red train, I'm going to call it, the other one leaves at 7:45 a.m. They're traveling in opposite directions. The red train is going 80 miles an hour and the blue train is traveling at 70 miles an hour. The distance is 210 miles apart. We want to know what time do the two trains pass each other. Now in the last video I kind of worked this out really quickly, and I basically showed you that with a timetable, if train A leaves at 7 a.m. and goes 80 miles an hour, they go 80 miles in 1 hour. They go another 80 miles in another hour. So at 9 o'clock, they've gone 160 miles. And you could figure out how far they go in these intervals. If they go 80 miles in an hour, they go 40 miles in a half hour, and half of a half hour would be 50 minutes. So they go 20 miles. It goes 20 miles every 15 minutes. And in the last video, I didn't explain this too well, but the blue train leaves at 7:45. It goes 70 miles an hour. So if it goes 70 miles in an hour, it goes 35 miles in a half hour, or it goes 17 and a half miles in a 15-minute window, in a 15-minute interval. So every 15 minutes it goes 17 and a half miles. So you can see how I got these numbers if you just keep adding 17 and a half, 17 and a half, 17 and a half. And what you do is you're looking for the combined distances traveled by the two trains. Where do they add up to make 210 miles? Because that was the original problem, right? 210 miles. Well, the answer that I got to then at time 8:45, that's where the trains met. And that was the correct answer, and that was our initial guess. But now let's do this with algebra. So let's follow this procedure more formally. So we've done the first part, we understand the problem. Let's pretend we didn't work with that timetable there and we just made an initial guess and said it was 8:45. Now we need to translate this problem into the equation. And this is probably the most difficult part for students. The first question I ask students is, what are your what's your unknown or unknowns in this problem? What are we trying to figure out? Okay, aren't we trying to figure out what time? This is the critical part here. What time will the two trains pass each other? What time? So let's set up, okay, let's solve with algebra. What are the unknowns? We need to know the time train A travels in hours when the trains meet, don't we? And we also need to figure out what the time the train B traveled in an hour when the trains meet, not when the trains meet. Okay, so what do we do when we have an unknown? We create what's called a variable. So we could use any letter. Let's just use T for time. Let's set T, let T equal the time train A travels in hours when the train meets. Now, for the second train, we could use another variable like X, Y, Z, but is the time train B travels related anyway to the time the train A travels? Well, let's look back at our original problem. What did we know? Train A left at 7 a.m. Train B left at 7:45. So in other words, it left 45 minutes later than train B. So This problem though is dealing in hours, miles per hour. They give us the speed in miles per hour. So we need to figure out how much later did train B leave after train A in terms of hours. This is 45 minutes later. What is 45 minutes in terms of an hour? Isn't 45 minutes t minus 3/4 of an hour, right? So this is, if t is the time that train A travels, then t minus 3/4 of an hour is the time train B traveled in hours. So in other words, if we figured out that t was 2 hours in this problem, so train A went for 2 hours, okay, this is t, then t minus 3/4 would be 1 1/4 hour, wouldn't it? Or 1.25? Because isn't t minus 3/4 the same as t minus 0.75? 0.75 is the same as 3/4 hour, right? So if train A traveled for 2 hours, train B would have traveled for 1 1/4 hours. It's okay. So now we can go ahead and set up an equation, and this is where we're going to use our information that we had from before, and we're going to use rate times time equals distance. So the rate or speed of train A in miles per hour times the time that train A travels, this will be the distance that the red train travels in a particular amount of time. We're going to add to that the distance that train B travels in a particular amount of time. What is the distance train B travels in a particular amount of time? Isn't it its speed or its rate times the time that it traveled? Okay, that has to equal 210 miles. Okay, so here is our algebraic equation right here that we're going to be able to solve. 80 miles an hour times the time it travels, we're going to use a variable t, plus 70 miles an hour times, well, the blue train travels 3/4 of an hour less time than the red train. So we need to say 70 times quantity t minus 0.75. I just changed that 3/4 to 0.75. That sum has to equal 210. So here it is again, 80 times t, I wrote them together, 80t plus 70 times quantity t minus 0.75 equals 210. Now how do you solve this? When you have a number outside of an expression with an addition or subtraction, you use what? The distributive property, or I like to call it the rainbow property. You draw a rainbow from the quantity outside the parentheses to each term inside the parentheses to remind yourself you've got to multiply. So 70 times t is 70t. 70 times 0.75 is 52.5. And this minus sign you just carry down right here. That's that minus sign. So 80t plus 70t minus 52.5 equals 210. Combine like terms, 80t plus 70t is 150t. 80 tomatoes plus 70 tomatoes is 150 tomatoes. Okay, now we got to get this 150t alone. So how do we undo subtraction? What's the opposite of subtraction? Addition. So add 52.5 to both sides to keep your equation balanced. Okay, you eventually get 150t equals 262.2. Now to solve for t, you divide both sides by this number, 150, because this is really multiplication going on here. How do you undo multiplication? You divide, and you get t is equal to 1.75. And this was train A's time. Okay, train A time. And right below this would be train B time. So train A is traveling for 1 3/4 hours, and train B traveled for that value minus 0.75 or 1 hour. So The answer becomes trains pass each other at 8:45. Train A started at 7, traveled for 1 3/4 hours, that's 8:45. Train B started at 8:45 and started at 7:45, excuse me, traveled for 1 hour and got 8:45. Thanks for watching.